Good morning, everyone. I'm Dr. Santhosh Reddy. We are a team of autonomous ground vehicles team in NMICPST. Especially, we work with vision-based navigation. So when we are talking vision-based navigation, our main target to drive an autonomous vehicle based on the camera RGB and stereo vision camera. So for that, to navigate an autonomous vehicle, we need some position. So to maintain some accuracy of position, as Risho was mentioning about GNSS based RTK based corrections. So when there is a correction in RTK or error is high, then we want to depend on the localizing of the vehicle with using RGB camera. For that, we want to detect the driving space detection on alternate driving space for obstacle avoidance applications. If there is a static application, static object on the road, like we want to avoid that object to navigate to ahead. So for that, we need an alternate driving space, whether vehicle can drive for further or not. So this is the main problem statement. We started to work on segmentation for driving and alternate driving space detection using BDD 100K dataset. So BDD 100K dataset is prepared specially for autonomous ground vehicles for driving space detection, lane marking detections, and objects around the autonomous vehicle on real-time road applications. So this is how we want to detect an alternate driving space and driving space. So to do this thing, like we took as a benchmark data set, BDD 100K data set, and we trained the model. So PSPNet architecture we used. PSPNet architecture is a pyramid scene parsing network. We trained this data set with multiple models from the literature survey. Some are working very good with better performance of real time in German or in US or Japan countries due to adversarial weather conditions. Whereas in India, when we came and we tested same PSP architecture along with ResNet 101 was giving the better performance in real time. Whereas in computer generated results, when we tested with valid test data set, all other models are giving better performance, but for real time, PSPNet was giving a better accuracy. So we used around 10,000 images and real-time video streaming from Tihan IITH to validate this data set. And these are the performance metrics we achieved, like accuracy 84%, MAP 90, and detection recall recall is around 86%. So from the literature survey, we identified LiDAR is used and some other lasers scanning sensors also used for driving space detection. For some laser scanners are used not for the driving space detection, for the maintenance of road conditions. So majorly LiDAR is used for the driving space detection, but compared to camera and LiDAR is a bit cost, form factor is high. So, so this is the overall architecture we used, and this is inside IITH in Tihan testbed. Maybe some of them had visited yesterday to the testbed facility, and this is the architecture of complete PSPNet architecture. And the final prediction we can see red color one is a driving space, current driving space. Green color of both sides is alternate driving space, where we can take the decision not only by depending always on the GNSS system, we can take by using localization of the vehicle. So this is the architecture algorithm we used, steps in the algorithm for detection of road space segmentation model. Around 1 lakh images, driving video clips and images were used for as a BDD 100K data set. All the annotations were done using segmentation task for road and lane segmentation. The data set covers both day and night conditions, rural, urban, road, and all weather conditions. Next, we are coming up with our own Indian data set specific to adverse weather conditions, where we have, like, without lane markings, without proper tar also, we want to detect the road conditions. This is the flow diagram of PSPNet road segmentation, how it is working. So this is the test tracks we have. Like, this is the only phase one. Now we expanded to phase two also, where we can test high-speed testing. Currently, we are using this segmentation model along with other alternative sensor data to test an autonomous vehicle around 60 to 80 kilometers per hour. Previously, we were testing an autonomous vehicle around 30-35 kilometers per hour. So these are the some of the data set what we saw in real time in Indian road conditions. This is somewhere in India, like I think Hyderabad or somewhere. So this is how in real time where sunlight all are affecting. This is the detections we observe. So we are improving as per the Indian scenarios. These are the different models we tested, and we accuracy we achieved. The best one is the PSPNet using ResNet models. This is the performance measures of different models which we used. The proposed model we got around 90 plus accuracy for real-time application. So in future, we want to develop our own architecture. On top of this, we want to wrap some more few convolution layers to identify best model and to meet the better accuracy. And data set also, we are coming up with our own data set specific to Indian road conditions. These are the some of the references. Thank you.